Good morning, and you're very welcome to this morning's webinar. I'm Dr. Elizabeth McGowan, Director of AFBI, and this morning we will focus on the nutritional solutions to environmental challenges within the pig industry. Today's webinar is being delivered from the very successful, long-established partnership between AFBI, John Thompson and Sons, Devenish Nutrition and PCM. Over the past 20 years, under the expert chairmanship of Professor Fred Gordon, with expert assistance and input from Dr. Kelvin McCracken, this partnership has delivered cutting-edge research in the area of pig nutrition. Over that time, a key thread of the research has been to reduce the environmental impact of pig production whilst optimising pig performance. In doing so, they have reduced the phosphorus and nitrogen excretion of pigs, and by investigating a wide range of alternative feed ingredients, they have also indirectly built a strong portfolio of evidence on feed ingredients to reduce the carbon footprint of pig production. Funding from DAERA over this period has supported this long-running programme, which has had a significant impact on the industry at large, due mainly to the nature of the consortium, since the partners themselves are the practitioners, and therefore the findings can be adopted directly and immediately across their wide supply bases. But as well as that, they also ensure that the wider industry is aware of the opportunities that exist to reduce excretions and emissions through forums such as this, as well as the booklet which they've produced. And if you haven't already received the booklet, you will be receiving it very shortly in your inbox. So today, I am delighted that we have Dr. Alistair Carson, DAERA's Chief Scientific Advisor, and he's in the middle right of my screen. I'm not sure where he is on your screen. Morning, Alistair. And Alistair will provide us with an introduction which really overviews the policy environment that we're working in, as well as outlining those key environmental challenges that we face. Dr. Elizabeth Ball, who's in the middle of my screen, and Elizabeth's lead scientist in AFBI on pig nutrition, she will then overview some recent findings over the years that has really led us to the findings that will be discussed here today. Dr. Linda Farmer, at the bottom of my screen, and give us a wave, Linda, is Head of Food Research Branch in AFBI. And it might seem a bit strange that the Head of Food Research in AFBI would be on a pig nutrition discussion forum, but Linda's been working very closely with the team around areas, some novel work, which is trying to understand the relationship between pig diets and odour compounds, as well as then extrapolation on into gut microbiomes. So then we have Mr. Sam Smith up at the top screen, and Sam is from John Thompson and Sons. And Sam will then take us further on that journey to understand the impact of crude protein in pig diets on the resultant ammonia emissions and odour offensiveness. So Sam and Linda's work really represents some very novel and groundbreaking studies which are providing us with new insights into the impact of diet on ammonia and odour emissions. As Sam and Linda present, please do be submitting your questions. And if you're not already familiar with WebEx, you should have a Q&A function down at the bottom right-hand side of your screen. So as Sam and Linda are presenting, please do submit your questions. And whenever Linda finishes, we'll take some questions for Linda. When Sam finishes, we'll take some questions for Sam. So don't be shy and make sure you submit your questions so that I can make sure we get as many answered within this morning as possible. We'll then take a short break because I'm sure we'll all be ready for a cup of tea and some sugar. And unfortunately, we can't offer it, of course, so hopefully you'll have the kettle ready yourselves. But after the break, we'll come back and Dr. Violet Beattie, who is a technical project consultant for Devenish Nutrition, and Dr. Elizabeth Ball then will also give us an overview of some recent trials which are really pushing crude protein further down in line with strategically grouping pigs, as well as investigating the amino acid balance of diets. Now, I would advise strongly that we listen to both Violet and Elizabeth's presentations together and don't make any conclusions until both presentations are finished, because together they formulate one whole story. And whenever Violet and Elizabeth conclude, we'll then take questions for Violet and Elizabeth after that, and again, using the Q&A function. Hopefully we'll have a bit of time at the very end for a panel discussion, where I'll try and wrap up any final questions. And lastly, like all good pig seminars from AFBI, there is a booklet produced, and I'm delighted with that. And as I said earlier, if it isn't in your inbox in the next few minutes, do let us know and we'll make sure that it does arrive in your inbox. And it very much complements what you will be presented with this morning. So with no further ado, Alistair, I'd like to invite you to give us an overview of what the policy background and environment that we're in at the minute, as well as those big environmental challenges. Thank you, Alistair.
Okay, thanks, Elizabeth, and good morning, everyone. I'm very pleased to be involved in this morning's webinar, and as Elizabeth outlined, I've been asked to provide a short introduction and background to the seminar this morning from a science policy perspective. So in the next 15 minutes or so, I will aim to provide hopefully some relevant policy background in relation to the environmental challenges facing agriculture. As the main focus of this technical seminar is on nitrogen utilisation in the pig sector and associated odour aspects, the latter half of my presentation will cover aspects of the ammonia challenge. So Sharon, if I could have the next slide, please, because I'm going to say a word on green growth. And across departmental green growth strategy for Northern Ireland is being worked on at the minute. DARD is currently leading on this development with the aim of transforming society to achieve net zero greenhouse gas emissions by 2050 and to protect and enhance our environment and sustainably grow our economy. The strategy will guide actions right across the Northern Ireland environment, economy and society, and work by officials is being led by our Permanent Secretary, Dennis McMahon, along with Tracy Teague, Chief Executive of the Northern Ireland Environment Agency, and Aaron Wright. It's important to highlight that science itself will play a key role in addressing the environmental, economic, and social challenges associated with growing and rebalancing our economy so as to achieve green growth. The challenges and indeed the opportunities are very significant, and we will need new technologies. We will need new radical approaches and new solutions to be achieved through robust science across all areas in line with the developing green growth strategy. Sharon, if I could have the next slide, please, an agricultural policy framework which leads on from the green growth strategy. The draft agricultural policy framework will form an important component of the green growth strategy itself. This policy framework is again about progressing economic and social ambitions for agriculture in Northern Ireland, whilst protecting and enhancing the natural environment. In developing this draft framework, the Department, in conjunction with key stakeholders, identified the following desired outcomes and long-term vision for the Northern Ireland agricultural industry. Increased productivity in international terms, so closing the productivity gap which has been opening up with other major suppliers. This will create the basis of a profitable sector which can grow market share. An industry that displays improved resilience to external shocks, and my goodness, we are more aware of these than ever, these external shocks which are becoming ever more frequent and to which the industry has become very exposed. An industry that is environmentally sustainable in terms of its impact on air and water quality, soil health, carbon footprint, and biodiversity. And an industry which operates within an integrated, efficient, sustainable, competitive, and responsive supply chain. A focus on transmission of market signals, and an overriding focus on high quality food and the end consumer. So moving on from the agricultural policy framework, I want to take this on through into the science strategy framework. So the next slide, Sharon, please. Science will be a key policy and delivery tool to achieve the outcomes which I've outlined in relation to the draft agricultural policy framework. In the department, we are in the closing stages of defining a strategy for how we will commission and use science in the future, so that it will be innovative, it will be collaborative, and it will be transformative. Around a quarter of the department's annual budget is invested in scientific services, which is a measure of a commitment to evidence-based decision-making and innovation. The Developing Science Strategy Framework has ambitious goals for the department in terms of science leadership. It also emphasises the requirement for the department to have a holistic, forward-looking, evidence-based understanding of our science needs. The framework also emphasises the need to optimise the value of the department's investment in science through, for example, wherever practical, engaging in collaborative science programmes to optimise partnerships and synergies and to optimise overall value achieved through our investment in science. It also highlights the importance of working with high-quality scientists, both internally and externally, who are to provide the science and associated expert scientific advice and specialist scientific opinion. Finally, the framework also covers off having a fit-for-purpose science infrastructure. Maximising the use of IT and data for science is a key goal. And finally, good governance of our science programmes is highlighted. Next slide, please, Sharon. So that's a high-level science framework. The innovation strategy is one of the operational strategies of this underlying the science strategy framework, which is currently being developed. Research and development and monitoring and surveillance strategies are also being worked on. So we look first of all at the innovation strategy and which is being worked on at the minute. The mission of the draft innovation strategy is to deliver an innovation ecosystem delivering for the Northern Ireland environment, social well-being and the rural economy through creating an enabling environment for innovation to flourish and enhancing the impact of knowledge generation and science investments. And through collaboration and exploitation, ensuring positive, measurable outcomes for the Northern Ireland economy and environment. Throughout the innovation strategy, it places a strong focus on creating an innovative culture, both within the department and with our key external stakeholders, providing effective leadership and enabling connections between government, industry, academia, and the wider society. Sharon, could you move on to the next slide, please? Today's seminar features science which incorporates many of the principles laid out in our policy framework. Its research and development help address a key environmental challenge, ammonia emissions for the Northern Ireland pig sector through reducing nitrogen excretion. Related odour issues will also be covered. You will be aware that ammonia is a form of nitrogen. It's caused largely by the management of slurries and manures and the spreading of fertiliser. 96% of ammonia emissions in Northern Ireland arise from agriculture, damaging many of our most valuable habitats through direct ammonia concentrations in the air and also indirectly by reacting in the air to cause nitrogen deposition. Ammonia is a particular issue for Northern Ireland due to the predominance of livestock farming. Sharon, could I have our next slide, please, which shows the critical level exceedance mapping. Critical level exceedance mapping shown here currently represents the best available evidence of where the impacts of ammonia emissions are likely to occur. Critical levels relate to the concentration of ammonia in the atmosphere above which direct adverse effects may occur. These critical levels, they aren't habitat specific, but have been set to cover two broad vegetation types, higher and lower plants. For lower plants, that's mosses and lichens, really, the critical level is set at 1 microgram per cubic meter. For higher plants, the critical level is 3 micrograms per cubic meter. Currently, 91% of special areas of conservation in Northern Ireland are exceeding the critical lower levels of 1 microgram per cubic meter for mosses and lower plants. Similarly, 89% of Northern Ireland areas of special scientific interest are exceeding the lower critical level. Because of the enterprise mix here in agriculture in Northern Ireland, the critical level exceedance is higher than in England, Scotland or Wales. Sharon, could I have the next slide, please, just giving an example of the impact of ammonia emissions. Just picking one example of the ecological impact of excess ammonia emissions. This photograph here shows the impact on sphagnum moss. Excess ammonia concentrations in the atmosphere causing increased algal growth, loss of structure of the plant, and ultimately the moss dies. As we know, sphagnum is a key component of peatlands which are so important for their biodiversity, carbon and water storage, and also because of their landscape value. It's also important to note that elevated atmospheric ammonia levels can also have detrimental effects on human health. Next slide, please, Sharon. So the vast majority of designated sites in Northern Ireland are currently experiencing ammonia concentrations and nitrogen deposition above the critical levels and loads at which damage to plants may occur. Over the period from 2010 to 2017, agricultural ammonia emissions increased by 20% and have reached levels similar to those experienced at peak levels in the late 1990s. These results are the result of increasing livestock numbers, greater use of indoor housing systems, and insufficient uptake of ammonia reduction measures. As you can see in this slide here, there was a slight decrease registered in 2018, but sustained and tangible reductions in ammonia are required to protect nature, to meet Northern Ireland's legal obligations, and to ensure a sustainable agri-food sector. Sharon, could I have a next slide, please, which shows the sources of ammonia emissions from agriculture in Northern Ireland. The main sources of ammonia emissions from Northern Ireland agriculture in Northern Ireland are presented in this pie chart. 2.5 kilotons of ammonia are estimated to be emitted from the pig sector here in Northern Ireland, which represents just over 8% of total emissions from Northern Ireland agriculture, as shown in the yellow segment here. Whilst being less than 10% of total emissions, the impact of ammonia is seen locally close to emission sources. And as pig units can be very large, discrete sources of ammonia emissions, their impact can be large, and the strategic importance in addressing ammonia emissions from the pig sector is therefore high. So let's look at the research that's been undertaken to address this issue. And if we go to the next slide, please, Sharon. To inform a policy, DARA has commissioned a large research programme on ammonia emissions led by AFBI, along with partners, the UK Centre of Ecology and Hydrology based in Edinburgh, and Rothamsted Research down in Devon. The research programme is addressing recommendations of the expert working group in the Making Ammonia Visible report. Key components of the programme include monitoring ammonia emissions at 28 sites across Northern Ireland. Work from the first year of this programme has showed good agreement between the monitored concentrations at sites across Northern Ireland and those estimated through the UK modelling chain, thus validating the comprehensive modelling chain in place to estimate ammonia emissions and atmospheric ammonia concentrations and nitrogen deposition across Northern Ireland. The research programme is also looking at the most effective ways of reducing emissions. This has included reducing the protein content of diets to pigs, today's topic in the seminar. And finally, the research programme has looked at environmental and economic modelling of ammonia reduction measures themselves. The findings of this programme were presented recently at a series of webinars and are still available through the DARA website. So Sharon, could I move on to the next slide, please? The principles behind ammonia reduction measures are based on reducing the nitrogen inputs into farms without reducing performance and improving the efficiency of nutrient utilisation. Today's seminar will present important data from the Pig Research Consortium in relation to driving down nitrogen excretion through crude protein and amino acid manipulation. This complements the ammonia science research programme and adds significantly to the evidence base underpinning an ammonia strategy, which the department hopes to issue for consultation later this year. Finally, before handing back to Elizabeth, I would like to recognise the dedicated work of the AFBI pig team in running the trials, and Elizabeth Ball at Hillsborough and Elizabeth McGowan as AFBI director in overseeing the work. Also to Fred Gordon, chair of the group, and Kelvin McCracken, along with the other members of the Pig Research Consortium, a number of whom will be presenting today. This is real collaborative work in action, and with very significant personal contributions being made to ensure robust data is produced, robust data on which solid decisions can be made to improve both economic and environmental performance of the pig sector here in Northern Ireland. So many thanks for your time and for your attention this morning. And I'll now hand back to Elizabeth to provide some additional background to the Pig Research Consortium research programme. Thanks, Elizabeth.
And I'm glad you didn't clarify which Elizabeth. It always gets complicated here in Hillsborough. But thank you very much, Alistair, for that very comprehensive overview of the policy environment and the big challenges and the challenge that ammonia poses for the pig industry. So Elizabeth Ball is now going to provide us with the background with regards to some of the recent research that has been conducted, which has really led to the trials that will be reported in this seminar. So Elizabeth Ball, thank you very much.
Thank you very much, Elizabeth, and good morning, everyone. I hope you all can hear me. It's a bit different in presenting in a webinar form than in our normal format. So hopefully you can hear me and you can see me while I can't see you. It gives me great pleasure this morning to set the scene of our seminar. And my first task is to take you back a little on our journey on working to reduce nitrogen excretion in pig production. I want to take you back to the very beginning of one of our first early studies in the area and take you through some of the implications that we have achieved with that work. So this first paper is really a step back in time to set the scene, to give you a background into our work. And while some of it won't be new, you may be aware of some of the work that I'm talking about in this first paper, and indeed some of it has been already implemented within the industry. But I think it's important just to give you the whole journey of our work on reducing nitrogen excretion. So by way of background, I just want to present this little diagram. This is a very simple diagram, and I want to highlight that it is very simple to reduce nitrogen excretion, because nitrogen excretion is just basically nitrogen intake less the nitrogen that's retained within the pig. So it seems to be a very simple solution. Let's just reduce dietary crude protein, and that will reduce nitrogen intake. But the message that we want to portray today, that while it's a simple idea, putting this into practice is not simple at all. It's very important to maintain production, or else nitrogen excretion will actually increase, and we will lose that benefit as if we reduce the production performance of the pigs. So as I said, I'm taking you back in a journey in time. The first step that we had along the road in reducing nitrogen excretion for Northern Ireland pig production was conducted probably around the late 90s and the early 2000s. And that was to optimize the energy to lysine or protein ratio. Very simply, energy to dietary protein ratio is critical, because an oversupply of energy at the expense of protein will result in fat pigs, and an oversupply of protein at the expense of energy will increase nitrogen excretion and also will increase the cost of diet production. So it's extremely important to provide that energy and protein at a level and at a ratio that is optimum for pig performance. Of course, within protein, we understand that it's the amino acid supply that is important within the dietary protein, and we can supply that amino acids through the ideal protein concept. And this is a concept that has been developed over 50 years ago, with the idea of supplying the amino acids in the exact ratio that is required by the pig. And as lysine is the most limiting amino acid in many of our feed ingredients, we always talk about lysine being first, and then the other amino acids are supplied in relation to lysine. So as we go forward in the presentation, I'll be saying lysine and other amino acids, but lysine is or the other amino acids are in reference to lysine. So I'm not going to go into many details of the different studies, but I'm going to give you the key points. So this first study was conducted on growing pigs from 8 to 12 weeks of age. We had 4 energy levels and 2 crude protein levels. At that time, the growing pig diets were around 23% crude protein. And we wanted to investigate if that could be lowered to around 19% crude protein and also investigate the effect of reducing lysine, see if there was any effect on performance, and also to see if there was any effect on nitrogen excretion. And there were many findings which came from this study, but of importance to our seminar today was that there was no difference in performance due to the crude protein level or to the available lysine level. And that led us to see that reduction in nitrogen excretion. So as you can see from this little graph, 23% crude protein diet resulted in a higher level of nitrogen excretion as when compared with pigs offered the 19% crude protein diet. And when this was calculated up, taking into account occupancy rate and number of pigs, this actually results in 750 tonnes less nitrogen excreted to the environment from growing pigs. So a significant reduction in nitrogen excretion, which has already been achieved through this research in the Northern Ireland industry. We then turned our attention to finishing pigs, as that is where the most gain can be achieved in terms of reducing nitrogen excretion. In order to replicate commercial reality, we offered the one finishing diet right through from the early finishing stage of 30 kilograms to slaughter. And just to note that when this trial was conducted around the mid-2000s, slaughter weight was lower at 105 kilograms than it is now. We investigated 5 different crude protein levels, ranging from 14% to 19%, and at that time the crude protein levels of finishing diets were an average, well, they ranged really from 17% to over 19%. And within those crude protein levels, there were 2 levels of available lysine, 0.7 and 0.8%. What we found was that in that very early finishing stage, the performance was poor across all the diets, indicating that they were all nutritionally inadequate at that very early stage. And then from 13 weeks onwards, we found that the lower level of lysine was not sufficient to drive optimum growth, and that was evidenced by the poor performance. Again, many things came from this trial, but of importance today is that the dietary crude protein did not affect the performance, but it was extremely important to balance the amino acid level and to supply lysine and amino acids in the quantity and in the ratio that was required to drive the growth. What it meant for the industry, well, we were able to use this information to go forward to seek a revision of the nitrates action programme. And by way of explaining just the impact that had on the industry, I put up here some of the old values that were used in the previous NAP programme compared with the revised values that we put forward as a result of the research. So as you can see, there was a kilogram of nitrogen less produced from wean to finish as a result of our research. And from a Northern Ireland pig farmer perspective, that meant that there was less hectares required to land spread slurry and adhere to the 170 kilogram of nitrogen per hectare limit. So again, this has been implemented in the NAP back in the 2011-2014 revision. So we saw that we could reduce crude protein, but we highlighted that there was a need to really focus on amino acid level and amino acid balance. And that led us onto another step of balancing amino acids. Now, I'm not going to go into details on this slide. All the information is available in the booklet. But we took formulating down in amino acids beyond what would normally be done in the commercial situation to take account of going down below the normal limiting amino acid or the normal essential amino acids that are supplied in the diet. And we also looked at different ways that amino acids could be supplied either in a free form or bound onto a sugar matrix. Again, we could have a seminar alone on some of the results of each of these trials, but to cut to the chase and give you the key points, we found that formulating down to tryptophan and valine was beneficial, and that going to tryptophan in the later stage had some advantages in terms of pig performance. We found that providing a sugar-bound amino acids can actually reduce the inclusion of synthetic amino acids and thus reduce diet costs. And then critically for our discussions today, we seen that it was possible to reduce to 15% crude protein when the ideal protein was balanced down to threonine and beyond. And just to show what that meant in terms of, or what that means in terms of nitrogen excretion, you can see the difference when pigs were offered 17%, around 38 grams per day of nitrogen excreted versus just around 30 grams per day of nitrogen excreted when offered a diet containing 15% crude protein. So our key findings: nitrogen excretion can be reduced by lowering dietary crude protein. Think back to that little simple diagram, but very important to ensure that production performance is maintained. And we can do this by getting the amino acid balance and the amino acid level correct, and that will ensure that our performance is maintained. Another key finding was that the NAP program was revised and updated to reflect these reductions in nitrogen excretion, and a significant proportion of producers in Northern Ireland have already reduced dietary crude protein in finishing pig diets as a result of this research, which has led to a substantial reduction in nitrogen excretion. But there are still some questions to be answered, and this has taken us along further along the road on our journey of working in reducing nitrogen excretion. And I want you to take a photo shot, if you like, of these questions as we go through the rest of the papers, because we feel we have provided answers to these questions and to these challenges. First question that we felt needed to be addressed in the second programme of research was, can dietary crude protein levels be reduced beyond 15%, bearing in mind the need for balanced amino acids? With boars, which have a higher requirement, would they respond differently with gilts when offered diets lower in crude protein and lysine? And considering the effect of slaughter weight, which has increased significantly in recent years, is there room to lower crude protein within that later finishing diet and thus reduce nitrogen excretion? And then, as Alistair has highlighted, ammonia and odour are particular problems within Northern Ireland, and we wanted to quantify the relationship between reducing dietary crude protein and what the effect is on ammonia and odour emissions within a Northern Ireland context. And then finally, we wanted to investigate different dietary methods to modify or manipulate the microbial profile within the digestive tract and investigate the effect that has on odour and ammonia emissions. So thank you very much for your attention, and I'll hand back to Elizabeth. Thank you.
Thank you, Elizabeth. So I hope you all in this new digital era did take a photograph of that last slide that Elizabeth Ball had, because we're going to work backwards on it. And therefore, next presentation is from Linda Farmer. And as I said earlier, Linda and Sam are going to present to us on some very novel work, which is trying to understand the relationship of the pig diet to odour emissions and ammonia emissions. So Linda, I now invite you to share your presentation and present to us on the work which is focused on looking at the fibre and fat content of the diet. And as I say, we're working backwards on that screen of questions that Elizabeth Ball put up earlier.
Okay, thanks very much, Elizabeth. And good morning, everybody. It's a great pleasure to come and talk to you about something a little bit different. We're still talking about emissions from pig houses, but focusing on the odour that we get rather than the rather than just ammonia. I'm not sure why this is running automatically. Sharon, are you doing this, or is this something that's happening? Okay, hang on a moment. Okay, hopefully it won't run away with me, because it seems to be doing its own thing here. Right, okay. The problem that pig houses often have is that not so much that they themselves have the problem, but that the neighbours tend to object to them because the odours from pig houses can be rather strong, and this has led to very tight legislative and environmental requirements around the development of pig houses and the pig industry. So it's of interest, therefore, to know what are the key compounds that cause those odours, and is there anything that we could do about them? And a few years ago, we did a little bit of a review on this, because there's a lot of publications about what compounds are out there and what compounds contribute, but not what their relative contribution was. And that's what we did. We used a technique that we use in flavour analysis, and we applied it to the odours from pig houses. And this is looking at something called odour activity values. And basically, if you know the concentration of a compound in the air, and you know the threshold at which people detect it, you can work out its odour activity value. And if it's more than one, more than half of the population will pick it up. And if it's a lot more than one, a lot of people will pick it up. So the bigger the odour activity value, the more odour it has. And what we can see here is that we've got a lot of different compounds. Don't worry about the names along the bottom. But the ones that are above the line have an odour activity value that is more than one. And if it's a lot above the line, then it's a very strong odour. And the first thing to note is this is ammonia. Now, we've already heard that ammonia is exceedingly important from the point of view of environmental impact. And it's also a very important contributor if you're standing in the pig house, because it has a big effect on making your eyes water and all that sort of thing. But if you're outside of the pig house and at a distance from it, it is not a major player in terms of the odour downwind, as it were. The compounds that do have a big effect are the acids, which we can see here, these red compounds. Some of the other amines, these tall ones in green. The indoles, including a compound called skatol, which is very characteristic of pig slurry. The purple ones, which are phenols, and the black ones, which are sulfur compounds, including hydrogen sulfide. So looking at those compounds, we've obviously got an odour that's made up of a lot of different substances here. And if we think about where those compounds come from, we can see that the acids are coming from proteins and carbohydrates in the gut. The phenols and the indoles are coming from microbial fermentation of certain amino acids. Ammonia and the amines are coming from the feces, but also the gut and the urine. And the sulfur compounds are often formed, particularly in the manure after it's been excreted. But all of these are related, therefore, to the microbiome in the gut, and also the microbial load in the feces. So microorganisms are playing a big part in all of these odours. What we also looked at was the studies looking at the effect of different treatments. I'm focusing on one here that relates to the diet and what they did to the odour activity value. So again, we converted the data that they were publishing in Hobbs 1997 into odour activity values. And you can see that in a dry feed, the odour activity values of the acids and the indoles, the phenols and the sulfur compounds, red, orange, purple and black, were very high. But the more water in the feed, the less impact that the acids and the sulfur compounds had, whereas the indoles and the phenols stayed about the same. On the other hand, there was another study that showed that if you covered the tanks, you could decrease the impact of the indoles and to some extent the phenols as well. So here we can see some fairly substantial changes due to diet. The study that I'm going to talk to you about today is looking at the effect of dietary fat and fibre on the odour in pig pens. What was the effect on the odour? What was the effect on the microbiome? And is there a relationship between the two? And we're still partway through some aspects of this study. To look at this, we had to use the environmental chambers at Hillsborough. That's because it's very difficult to do this in a normal pig house, because generally they all share the same airspace, and it's very difficult to know which odour is coming from which group of pigs. So we went for individual pigs in the environmental chambers, and you can see some photographs on the right-hand side there. So these boars were brought on, got accustomed to the diets, and then in the final week of their lives, they were put in these environmental chambers. There were 6 pigs from each diet in total, and there's 6 pens, so we did it six times over a period of 6 weeks or so. And when they were in the pens, we monitored the air for the odour quality, the volatile compounds, ammonia, hydrogen sulfide, and we also sampled faeces and intestinal contents as well. The diets that we used were a high fibre indigestible, high indigestible fibre diet with high or low fat, a low fibre diet that's high in starch with high and low fat, or a high digestible fibre with high and low fat. And the information is provided in this slide on the analysis of that diet, or the formulation of that diet. And you can see we've got higher levels of oil in the high fat ones and higher levels of fibre in the high fibre diets, more starch in the low fibre diet. And the analysis, when it came through, showed that we'd achieved what we desired to achieve there, that we've got higher levels of oil in the high fat diets and higher levels of fibre in the high fibre diets. Elizabeth Ball and her team were looking at the growth data, and there were some effects of diet on the daily feed intake and average daily gain, but there was no significant effect on feed conversion ratio overall. Now, obviously, because we were doing it in the environmental chambers, this is, compared with many dietary trials, fairly small scale. And we're looking to see further data from the commercial trial from stage B of this project to see if it confirms the information we had from these 36 pigs. Looking at the odour emissions, this is analysed by Silso, and they take a bag of odour and they put it through pipes and get people to assess it for its intensity. And I've plotted it here so you can see all of the individual values, because that shows that there's actually quite a lot of variation. In terms of the odour emission values, it's going from 0.5 up to 3. So there's quite a lot of variation between the individual pigs and pens that we have here. And there's no significant difference between the 6 different diets. Likewise, in terms of hydrogen sulfide emissions, there's no significant effect of diet. But what you can see is that the variability, which is high for diet 6 and for diet 3, is very tight for diet 1 and 2. So the indigestible fibre seems to be reducing the variability here of the hydrogen sulfide emissions. Ammonia, again, we're seeing a similar effect, a lot of variability, but maybe less variability from the high indigestible fibre pigs. If we look at the odour volatiles, then this all gets very complicated, and you'll be glad to know I'm not going to go through the detail of this slide. But what we're looking at is the same compounds again that I was showing you in the slide a little earlier. So we've got acids and sulfur compounds, a number of aliphatic compounds that don't have a big effect, and phenols and indols, including this compound statol here. And what we can see is that of the 15 compounds that I've listed there, only 5 of them had significant differences. And I'm going to show you a little bit more about some of those. So if we look at the sulfides first, well, the first thing is dimethyl trisulfide showed no significant effect at all. But we did see an effect of dimethyl disulfide, which is a fairly odorous compound. And you can see that, again, the levels for diets 1 and diets 2, the high indigestible fibre diets, seem to be lower than some of the others, and the high starch, low fiber diets seem to have high levels of these sulfide compounds. There was no effect of fat for any of these, so we're tending to find things grouped in twos in nearly all cases. If we look at the indoles, here we've got indole and skatole. Again, we've got slightly higher levels in the low fiber, high starch diet, and certainly in one of them for the skatole as well. So overall, as I mentioned a moment ago, we're not seeing any consistent effect due to fat. So a high fat diet is not increasing the amount of odour. But there were some trends for differences due to the indigestible fibre or digestible fibre or an absence of it, in that the high indigestible fibre is tending to give lower acids and sulfides and possibly more consistently low hydrogen sulfide and ammonia. The low fibre, high starch ones tended to be high in sulfides than some of the indoles, and the high digestible fibres tended to be low in indoles and sulfides and higher in acids. And if you kept, I haven't shown you the analysis, if you kept the feces for a number of weeks, it's amazing what science requires you to do sometimes, then these ones had lower phenols than the other treatments up here. We also, as I said, looked at the microbiome, and this is a very complicated field, and we had help from the London School of Hygiene and Tropical Medicine on this one. And this showed that the microbiome diversity is affected by the location of gut sampled and the time at which it was sampled, but there was no clear and consistent effect of diet. But that is still under investigation. We're still looking at that, and there may be more information yet to come. So in conclusion, fibre type and fat may affect performance, but there's no consistent effect on feed conversion ratio. Maybe the larger scale trial in stage 2 will show a bit more on that. There's no significant effect on odour emissions, hydrogen sulfide or ammonia, but higher levels of indigestible fibre seem to reduce variability. The pig house odour compounds were not affected by fat, but there were some effects of fibre, including lower levels of acids and sulfides with high indigestible fibre, and higher levels of some of these compounds with the high starch, lower fibre diet. Overall, the effect of fibre on these pig house odours were rather less than what we saw using the liquid diet from the paper that was published in '97, or indeed from covering the tank. So it has to be taken in context that there may be some modest effects of fibre, but that needs to be considered along with other measures that might be taken to reduce some of these odours. Thank you very much.
Thank you very much, Linda. And maybe just if you're not aware, maybe turn on your camera so we can see you. So folks, don't be shy. There's a Q&A button down the right hand side of your screen. Please do use it. But I do appreciate the first presentation out of the starting blocks there with regards to this issue is a complex one. And I think it's really interesting to start teasing out the specific compounds within the odour piece that actually can cause that offensiveness. So Linda, just from your work, I'll maybe just give you a quick question, and hopefully it's not an unfair question. You know, and I know it's early days on the dietary piece, but through the literature review that you conducted previously and your involvement with the group and reading around this subject, have you any kind of advice at this moment in time how maybe odour could be best reduced or you know, for pig farmers?
I think it's a very complex area, and there are many different factors involved. And I think we've talked around this a lot about exactly at what point is the odour released. And I think if it's an odour released from a pig house, then there's a possibility of, I hesitate to recommend things because I know there are many factors here, and you could, whereas it's fairly clear that increasing the amount of water in the diet will reduce certain odour compounds, I'm well aware also there'll be lots of other factors in terms of the production of the pigs that are going to come into that story. So it's not something that I, as an odour chemist, would wish to recommend as such. But there are things there that have been shown to have an effect. Certainly covering the slurry tanks may well have an effect. And it may be that, and again, altering the geometry of your facility is not a straightforward thing to do either, but there may be things that can be done there. I think the conclusions that I have drawn is that it is very much a multifactorial problem. And probably the answer for one pig farm with one form of geometry is not going to be the same as an answer for another one. And I think it's a question of looking at all the possibilities and combining them. The other interesting thing that came out from the wider studies that we did is that no one method reduces all compounds. And as I mentioned earlier, if you add the amount of water, increase the amount of water, you'll reduce the acids and the sulfur compounds, but you make no effect on skate oil at all. Covering the tank will reduce the amount of skate oil, but it won't alter the acids or the sulfur compounds. So I'm afraid the answer is that there is no simple answer.
Yes, yes.
That is a horrible scientific answer to something, but there's nothing I could say, well, in all cases, this will help, because I don't think there is such an answer as that. And I think if there was, I suspect the industry would have worked it out sooner anyway.
Okay, thank you. Just a very quick question here from Martina. Were there any changes in the feces characteristics in the different diets? And maybe Elizabeth Ball or come in on that. We maybe didn't measure so much of the feces characteristics, did we?
I think there's one comment I can make, and I'm relaying the comments from our commercial partners when we did the farm trial, that the high digestible fibre diet tended to cause the pigs to be rather loose, shall we say, and that caused certain production issues during that trial. I don't know, and Elizabeth may be able to comment on whether we measured anything like that in the chambers, but in that instance we had pigs living the life of luxury in an individual chamber, and the feces tended to be discrete little piles in the corner rather than the sort of effect that you get in a well-populated pig pen. So it may not have been just the same.
Okay. Thank you, Linda. And I think if Ursula McCormick could voice, she maybe would agree that some pigs were looser than others, let's say.
Yes, absolutely. Yes, we did measure dry matter of the slurry in the chambers. I'm just looking to see if it's in the booklet. We had slurry output in litres per day, so you can find some information of the feces characteristics in the booklet paper.
Okay, thank you. Thank you, Linda. Thank you, Elizabeth. So we'll move on now to Sam. And Sam is from John Thompson and Sons, heavily involved in the research programme there. And Sam is now going to present to us some of the work then looking at crude protein and its effect on ammonia and indeed odour emissions as well. So thank you, Sam.
Okay, good morning, everyone. Just by way of very quick background, we have covered most of this in a few of the earlier papers, but as an industry, we are obviously very, very aware of the problems that we face in relation to ammonia, despite it actually only being maybe 78%, as Alistair referred to earlier on, in terms of the overall contribution. We still have an obligation and a responsibility to meet our legislative challenges. We still have to be compliant with our planning and IPPC regulations and be very aware, as Linda said, of our neighbours. But at the same time, when we're discussing things like sustainability, we have an economic sustainability responsibility as well. We have a pig industry there that is punching well above its weight in terms of overall value to Northern Ireland economy. And I think those are things that we'll try and bear in mind as we're going through this presentation, as well as the subsequent ones, really with an ultimate aim of trying to be sustainable economically and environmentally. But in relation to ammonia, I suppose we have two options really to see what we can do in terms of reducing the levels. We can look at the nitrogen intake, improve the nitrogen retention, and then hopefully reduce the nitrogen excretion. Or we can have the focus on the slurry and try to reduce the amount of volatilization that's coming from the actual process that's happening in the slurry tanks. For the purpose of this piece of work, we're focusing on the first option, where we'll be looking at a range of different protein levels and what impact these had on finishing pigs for odour and ammonia and overall slurry production. The treatments themselves, we had 5 replicates of 6 boars. These boars were actually put on a standardised feeding regime before the actual treatment, and they were on a fairly high spec commercial grower feed up until 45 kilos, and then on to a first stage finisher up until about 75 kilos. Pigs then moved on to the treatment diets and stayed on the treatment diets for a 3-week acclimatization before they moved into the respiration chambers. During that 3-week period, we actually did some collection of feces to give an indication of things like digestibility of some of the key nutrients. In terms of our treatments, we tried in first treatment there to replicate what we've seen as probably a reasonably typical single stage finishing diet, 18% crude protein, which we typically fed the whole way throughout the finishing pig's life. Treatment 2 then was a reduced crude protein, which was more representative of some of the commercial lower protein management systems that actually were out there at that point in time. And then we decided for treatment 3 to say, listen, could we push this anymore? We're dealing with a 75 kilo pig. Could we reduce the protein and the lysine levels further? So number 3 was our stretch to see how far we could go. We obviously did our QC throughout the normal remit of the trial, and we got very good agreement on the treatment 1 and treatment 2 in terms of targeting, but treatment 3 actually threw up a little bit of an anomaly, formulating to try and hit a 12% protein target, but we consistently over the treatments actually had these analysing out at 13 rather than 12. But a little bit of an investigation has sort of maybe thrown a degree of sort of validity over the use of the 6.25 times nitrogen for a protein calculation, and this may not be completely valid and completely appropriate when we get down into lower protein and lower soy diet. So there's a little bit of an anomaly on that one, but for the purpose of this trial and for subsequent trials, we're classing treatment 3 as a 13% crude protein diet. As we said, after the 3 weeks, the pigs actually moved into the calorimetry chambers, and during that period, they had a 24-hour settling in, after which time we switched on the analyzers and recorded the gases actually for up to about 72, 73 hours. During that period of time, we actually had some point source odor sampling, 28 hours into the recording period. And we also collected and stored the slurry that were in each of the individual chambers below the pigs. As we said, in terms of the point source sampling, we actually had Silso, who come to AFBI, did the sampling and took the big bags of gas actually back to England for measurements. Linda has briefly referred to the process there, so we'll not spend much time on that. But in all reality, what we were looking for was a low odor unit per second, which dictates basically and shows it's a low odor figure. A few photographs really just to show the respiration chambers. The technicality of these we will have to refer to some of the AFBI experts, something I don't know a huge amount about, but just an indication of how the trial was set up. We also measured the performance, not for to see how the diets actually were performing, but we wanted to make sure that the pigs were growing normally, they were healthy, and we also then looked at the digestibility data that we had. So neither the digestibility data or the effect of crude protein on the performance was significant. So we were able to confirm that the pigs weren't stressed, happy enough in the environment, and that the data that we were getting would be valid in terms of all our subsequent gas analysis. as expected, with the reductions in crude proteins in the diets, we got 17 and 27% reduction in nitrogen intake. So that's really just coming through from the overall reduction in crude protein in the feeds. Did that transfer then into reductions in ammonia? And yes, it did. When we dropped down to the 13% crude protein diet, we got up to a 48% reduction in ammonia emissions. Now that 48% is very much in line with what other literature would say when they look at a sort of a holistic average of that every 1% crude protein that you may pull out of a diet could deliver somewhere in the range of 8 to 10% reduction in ammonia emissions. We didn't get the same ratio or the same relationship when we dropped from 18 to 15%. But we're looking into that and basically saying, well, why did we not get that relationship at 15% protein? It could be that the figures quoted in the literature are over quite a large live weight range. We could have differences in the methodology of ammonia measurement. But we also could be in a position, and we have to bear in mind that these were individually housed boar pigs, and it may be actually that when we get into a situation of growth requirements, that these boar pigs maybe actually still had a high need for nitrogen retention for growth at these higher levels of protein, hence maybe not actually excreting as much. So we'll cover a little bit more about the boars and their requirements later on in subsequent papers. But overall, I think we got a nice reduction in ammonia levels and up to 13% or up to 48% reduction when we dropped down to the 38 or 13% crude protein. I think importantly, from a Northern Ireland point of view, this work basically will validate what we're actually seeing. So for those farms who actually have adopted these regimes on farm, we basically can say, yes, Northern Ireland pigs in the Northern Ireland situation are able to deliver these sort of figures. We also looked at the water usage, and basically fairly large reduction in water usage for the pigs as well. Dropping down the protein levels, we've seen up to about a 25% reduction in water usage when we drop down to the 13% diet. Going from the 15% down to the 13 didn't show an awful lot of further improvement, but we're looking at that and basically saying that we've probably hit a sort of our floor or baseline for deamination, probably in around that 14 to 15% crude protein mark. So we're getting very little further benefit by dropping the protein down, but still up to a 20-25% water reduction, which in theory could have actually quite significant impact then in terms of slurry. So we obviously progressed into our slurry analysis, and the reduction in water usage is obviously showing itself in terms of the dry matter of the slurry content. Quite large increases in slurry dry matter when we get up to the or down to the 13% crude protein diet. Just dry matter of the slurry increasing up to 54%. Likewise then in terms of the actual total volume, when we were dropping from 18 down to 15 and 13%, these pigs actually in the chambers were producing over a litre per day less of slurry, which in both cases there is working out about 38%. We think that similar effect that we're seeing on the flattening out of the reduction in water usage from 15 to 13 is really sort of following through, and hence why we're not seeing much of a reduction in difference between 15 and 13%. But what does that mean? It's obviously fairly big figures. If we try and translate that into a single contract finishing house, for example, 640 finishing space house, turning over 3.5 batches per year. And if we base that on the standard figures that's in the NAP update there of 0.03 meters cubed of excreta per pig per week, that 38% reduction is the equivalent of 327 meters cubed, or in old money is 36 2,000 gallon tankers per year. So there's a fairly real and fairly tangible figure there in terms of what this can do in terms of overall slurry produced, which will have its knock-on benefits obviously then in terms of nitrogen and phosphorus loading as well. As we said, Silso come on site and did all the odour analysis, and they analysed for the odour offensiveness, which Linda referred to earlier. Now in this case, contrary and different from what we've seen in some of our other analysis where we were getting fairly strong statistical effects, we got no statistical effect on the odour offensiveness when we reduced the protein down from 18 to 15 to 13. We did get a numerical reduction, but the stats didn't actually say that this was significant. But I think of note, if we try and actually benchmark the figures, we got 2.2, 1.9 and 1.8 OUEs per second, which is an average of 1.94. When we look at that in relation to the literature, it's very, very low. We're seeing figures in the literature from the mid-teens to the high 20s over a range of different finishing pig situations. So we're at a very low baseline figure of odour to start with. Very similar picture to hydrogen sulfide, which were also analysed at Silso, where we got a no significant effect of the protein, but a nice numerical reduction, which could have potential implications on farm situations. I think any ability to reduce the likes of hydrogen sulfide on a farm is of value. We mentioned earlier that the figure of 1.94 was a very low and inherent figure for odour. Part of the reason for that may be that these figures and samples were only taken 28 hours after the odour analysis. So we had 24 hours of settling in and then 28 hours of before the odour sampling were taken. So maybe not a huge amount of time for any odour generation through the process of the bugs and the slurry to have an impact. We also had to bear in mind that for every treatment that we went through and every rep, the slurry chambers were cleaned, slurry pits emptied out, and nicely dried all prior to use. So we're in a very clean environment, which probably wasn't predisposing any high odours. But still, same treatment across each of the treatments and each of the replicates. But thankfully, we had stored the slurry from each of the chambers in buckets, and we were able to carry out then some further analysis. Now, a little bit as Linda was mentioning earlier on, these were tested with Linda's team for a range of volatile odour compounds, but we've seen no effect of the reduced crude protein on the vast majority of the compounds that were actually tested. The only one which, again, Linda did refer to, which we did see an effect on, was skatol, where we actually seen a positive impact, where the skatol levels actually increased when we dropped down to the very low crude protein level at 13%. Now, this obviously warrants further investigation, but we're looking into the effect of, limiting amino acids when we get down into these very, very low crude protein levels. So something certainly to be aware of when we're looking at the impact of odour. Linda did mention earlier on that the ammonia is listed as one of the odours compounds, maybe not one of the most significant ones, and the literature would suggest that there's not a great relationship between odour and ammonia. But we thought we would look at that, and we pulled together all our data analysis from our ammonia and our odour figures, ran the statistics basically to see were we seeing any relationship from our own work. Now, although not a particularly strong relationship, we were able to see a relationship. So the work still does suggest that reducing the crude protein and reducing the ammonia level will also be positive in relation to reducing the impact of odour. So in summary, by reducing the crude protein levels in the diets as we had per our treatments, we were very much in line with the up to 10% reduction for every 1% reduction in crude protein. I think, as we mentioned earlier on, very important just to put this into Northern Ireland context, in that a lot of Northern Ireland farmers have already adopted some of these dietary regimes, so already contributing significantly to reducing the ammonia emissions from pig units here in Northern Ireland. The lower crude protein, the impact it had on water and subsequent slurry volumes. So again, those people who have applied those dietary regimes are seeing the benefits of those lower amounts of slurry being produced from pig houses. We didn't get statistical significance, but the numerical differences we got between odour emissions and hydrogen sulfide certainly suggest that there's a positive influence and something we should be continuing to look at in terms of reducing the crude protein to keep our hydrogen sulfide and odour levels at a minimum. We did see a relationship between odour and ammonia, but I think as we'll see in probably more of the subsequent papers, we have to be very, very focused on the actual performance of these of the animals. It's not just a matter of dropping crude protein. We have to make sure that we look in detail into the overall balance of essential nutrients in the diet, including our amino acids. And finally, just to acknowledge and thank DAERA for their funding for the project, the rest of the industrial partners, for all the AFBI pig staff unit who did all the dirty work, and Alan Gordon for his stats, and ADHB for providing some additional funding to help one of the PhD students who contributed to this piece of work. So thank you.
Thank you very much, Sam. It's fascinating. I think it's really novel work, you know, using the chambers to really try and establish, you know, this relationship between diet, ammonia, volatile compounds, odour offensiveness. So folks, remember Q&A button down the bottom right of your screen. Please do bring in your questions, but I'll maybe ask you a quick question, and hopefully, Sam, it's not an unfair question.
Okay.
Have you had a chance? Has the consortium had a chance to think through how reducing crude protein, reducing ammonia would then actually create that, albeit weak, but positive relationship with odour? And I'm assuming it's odour offensiveness that it's been correlated against. Yeah, well, I think sort of following probably through to your similar question to Linda earlier on, we did discuss this at one of our last meetings, that the dietary direct impact of diets in terms of reducing odour is a difficult one. It is a challenge, and I think Linda's work, you know, showed that, and also our own study here actually showed that it's difficult to have a very strong influence. But I think one of the things that we actually see when, you know, we see this commercially as well as in our trials, that when we actually reduce the crude protein, the impact that we have on things like water usage, the pigs are cleaner. The pens are drier. So if we go back and refer to things like the best available techniques in IPPPC for management strategies to reduce the amount of odour coming from a pig unit, they're all focused on actually keeping the pigs clean, keeping the pigs dry. And that's probably where we have greatest impact in terms of actually having a positive overall odour influence, is by the sort of indirect effect that we actually have in the pigs in the house. Commercially, we see very clearly that any of the ones that are on these type of lower protein diets, pigs are very clean, pens are very dry, you know, and that obviously has its a positive influence, probably indirectly, on the overall odour coming from the houses. Okay, thank you, Sam. You've asked a guys question. There's guys and girls here, so I'm not quite sure if you want to finish off your question there, but we have reached 11:15, and I think we'll maybe take a break now and get a cup of tea and our sugar fixes wherever they may be. And if I could maybe ask folk to come back for 11 o'clock, and we'll get going again after the break at 11 with Violet and Elizabeth on that whole story around actually the impact of reducing protein on performance, and indeed the complication around needing to really balance the diet and focus on the amino acids alongside that agenda. So folks, thank you very much for joining us for the first half of this morning. Please do go get the kettle boiled, get a cup of tea, get a biscuit, and join us back at 11 o'clock. Thank you.